Hey there. Tonight we're heading somewhere no one's ever gone. Not because it's forbidden, but because it might not even exist in the way we think it does. You and I are standing at the edge of everything. The final frontier. The place where the light from the farthest galaxies fades into silence. Welcome to Dreamy Science. And tonight we're asking, what lies beyond the edge of the universe? So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And while you're at it, drop your location and local time in the comments. I love seeing where all these sleepy stargazers tune in from. Now, dim the lights. Maybe turn on a fan for that soft background hum. And let's ease into tonight's journey together. The universe has an edge, or at least, that's how your brain insists on imagining it. You picture some kind of shimmering boundary, like the event horizon of a black hole, marking the place where existence stops and nothing begins. But the truth, whispered by cosmologists and sung by the background radiation itself, is stranger and softer than that. There is no wall, no cliff, just distance. And beyond that distance, silence. You look out, in your mind's eye, into the inky fabric of deep space. Galaxies shrink to pinpricks, then vanish. The light that reaches you now began its journey over 13.8 billion years ago, before Earth was even a concept, before atoms in your body were fused inside stars that no longer exist. That light has been stretched, like taffy pulled too thin, into radio waves so faint they hum just above absolute zero. Every direction you gaze leads to the same thing: the cosmic microwave background. The universe's baby picture, taken just 380,000 years after the Big Bang. It's not a photograph of space. Really, it's a fossil of temperature. Tiny ripples, warm spots and cool spots that would one day grow into galaxies, stars, and eventually, you're looking not into space, but back in time. The edge of what's visible isn't an edge in distance. It's an edge in memory. Beyond that, the universe keeps going, but we'll never see it, because light from those regions hasn't had time to reach us. Imagine blowing up a balloon. Every point on the surface moves away from every other point as it inflates. There's no center on the surface, just expanding distance. Now pretend you're an ant crawling on that balloon. You'd never see the whole shape. To you, the surface feels endless. That's your universe. You're the ant, crawling on a four-dimensional bubble of space-time, unable to peek off the surface to see what it's expanding into. Scientists still argue whether it's expanding into something at all, or whether space itself is stretching, without any external backdrop. That's the real cosmic paradox. The universe is getting bigger, but there's no outside for it to expand into. And yet, even that idea has limits, because there's a part of the universe, far beyond, where your telescopes can see, where light itself gives up the chase. The expansion of space there happens faster than light can travel, pulling galaxies away at superluminal speeds. You'll never witness their future. They've slipped permanently beyond your cosmic event horizon. They're gone, not destroyed, just unreachable. That's when it hits you. You're not standing at an edge like the rim of a cliff. You're adrift inside an ever-growing bubble, where the concept of edge itself dissolves. And yet, you still can't help but wonder, what's on the other side of that horizon? Some theories suggest there could be more beyond it. Entire regions of space with different physics, different constants, maybe even different types of matter. Others say there's nothing beyond, nowhere at all, because beyond only makes sense inside space, and space itself ends there. You exhale slowly. The air feels heavy, as if your breath itself is part of that expansion. You're both observer and participant, a tiny patch of awareness woven into a fabric that's still unfurling. In the end, you realize the edge isn't a place. It's a limit of perception. The true boundary isn't out there, but in your ability to see, to measure, to imagine. And yet, imagining it is exactly what makes you human. Somewhere out there, beyond the reach of every telescope ever built, there might be light still traveling, galaxies still spinning, stories still unfolding. You'll never know. But tonight, you get to feel it, the quiet hum of everything that ever was, expanding into everything that might be. You're floating, now drifting above a sea of galaxies, each one a pinwheel of light and gravity. They scatter around you like luminous embers, drifting apart as though pushed by invisible hands. This is the expanding bubble, the ever-growing fabric of space-time that defines our cosmic home. The universe isn't static. It breathes. It stretches. It grows. Every second, galaxies move farther from each other, not because they're flying through space, but because space itself is stretching between them. The distances widen, silently, without any wind or noise. You wouldn't feel it happen. You wouldn't sense the slow elongation of reality beneath you, but it's there, everywhere. You look out, and it's like watching dots on the surface of a balloon being inflated. From your point of view, every dot seems to move away, but none are special. There's no center. The universe isn't expanding from one point. It's expanding everywhere at once. You're standing still, and yet you're being carried away, surfing a tide of nothingness that flows faster than imagination. You think about the galaxies at the edge of what you can see. They're already ghosts frozen in time. Their light left billions of years ago. So what you see tonight is their ancient echo. If you could travel there now, you wouldn't find them as they appear in your telescope. They'd be older, redder, perhaps already dead. This redshift, the stretching of light as space expands, is the universe's fingerprint. The farther away a galaxy lies, the more its light is shifted toward red. It's the same effect you hear when a siren passes by, a drop in pitch as the sound source moves away. Except here, the sound is light, and the movement is cosmic. And then, the mind-bending part. Some galaxies are moving away from you faster than light. It's not because they're breaking Einstein's rules, but because space-time itself can stretch faster than any traveler can move through it. It's like standing on an escalator that's speeding up beneath your feet. You're not walking, but you're still moving. Scientists call this the metric expansion of space. It's not a wind or an explosion. It's geometry itself changing shape. And that means wherever you are in the universe, you can think of yourself as the center of expansion. Every observer in every galaxy sees everything else receding from them. It's the ultimate cosmic ego trip, though. To be fair, everyone else feels exactly the same way. You glance down and imagine a grid stretched across all directions. Each square grows larger over time, but the squares themselves remain where they are. That's space expanding. It's like baking raisin bread. The dough is the universe, and the raisins are galaxies. As the dough rises, the raisins drift apart, even though they're not moving on their own. Somewhere, a cosmologist is smiling at your mental bakery. But this expansion isn't gentle. It's accelerating. The discovery shocked scientists in the late 1990 seconds when distant supernovae revealed that galaxies are not only flying apart, but doing so faster and faster. Some mysterious force, now called dark energy, is driving it. No one knows what it is. Maybe it's the energy of empty space itself. Maybe it's a new kind of field, stretching and pulling at the seams of reality. Fringe theorists whisper about vacuum decay, a terrifying idea that the universe might someday snap into a new, lower energy state, rewriting physics in an instant. You probably wouldn't survive that. But then again, neither would anyone or anything else. Still, most scientists think we're safe for now. The expansion continues, slow but unstoppable, like a tide that never turns. Over billions of years, galaxies will drift so far apart that even their light won't bridge the gap. The night sky will go dark, not because stars have died, but because their glow can no longer reach us. The universe will slip into silence. It's a strange thought that you live in a moment when the cosmos is still visible, a brief window when light from distant worlds still paints the sky with clues about its past. Someday, those clues will fade. Future beings, if they exist, might think they live in a small, lonely bubble, unaware that billions of galaxies ever existed beyond their reach. Scientists still argue whether the universe will expand forever or eventually slow down. Current evidence says it's eternal, but physics loves surprises. Maybe dark energy changes over time. Maybe gravity will claw back the cosmos in one grand reversal. Or maybe, just maybe, there are hidden dimensions where that pull is already happening, unseen. For now, all you can do is float weightless, surrounded by the silent ballet of galaxies receding into infinity. You're not just watching expansion, you are part of it. Every atom in your body stretches with the same invisible rhythm. The space between the particles that make you up is swelling imperceptibly, just like the universe. And so, the farther you look, the more you're really looking inward at yourself, as a product of expansion, a ripple in the same cosmic ocean. The edge of the universe isn't something you reach, it's something you carry with you. Everywhere you go, you drift farther outward, into a place where time and distance start to twist together like strands of smoke. Out here, at the very limits of what your imagination can hold, even the meaning of motion begins to blur. You're not just moving through space anymore. You're moving through time itself. This is the vanishing point of time, where light travels so far that it becomes a kind of memory rather than a message. You're looking back across billions of years, so deep that now loses all meaning. Every photon that touches you is ancient. Every sparkle in the dark sky, a relic of a past that no longer exists. You're surrounded not by stars, but by ghosts. Imagine this. As you gaze toward the edge of the observable universe, the light you see was born when the cosmos was just a child, 1/100th of its current age. Those galaxies have lived entire lifetimes since then. Some may have collided, others may have faded into dust. You're witnessing their youth, while they, if they could somehow look your way, would see your past in return. It's like being trapped in a hall of mirrors that stretch across time. Each reflection shows a younger version of reality, slightly fainter, slightly redder, slightly older. You can never see the present, only the echoes of what once was. Einstein warned us about this. According to his theory of relativity, time and space are inseparable. The faster you move through one, the slower you move through the other. So as the universe expands and stretches, time itself becomes elastic. Out here, near the edge, the distinction between before and after begins to dissolve. You reach out your hand, though you're not sure what that even means here, and you can almost feel the drag of time, like swimming through syrup. Clocks tick slower, distances stretch longer. You can't tell whether it's you moving away from everything or everything moving away from you. It's both. Mainstream physics tells you that time began with the Big Bang, but fringe thinkers sometimes wonder if that's just our local version of time, like a regional setting in the cosmic software. Maybe there are other times, running parallel to ours, other arrows of causality that never intersect. In those timelines, your future might already have happened, or maybe it never will. Scientists still argue whether time itself had a beginning. Some models, like loop quantum cosmology, suggest the universe bounced, contracting before it expanded. If that's true, the moment we call the Big Bang wasn't a birth, but a transition. The universe could be eternal, pulsing through endless cycles of expansion and contraction, like a cosmic heartbeat. It's an oddly comforting thought, isn't it? That even if everything fades, it might one day rise again. New atoms, new stars, maybe even new versions of you, scattered across an unthinkable future. And yet, the further you go, the slower everything seems to get. Time here isn't linear, it's gravitational, stretched by mass, warped by energy, tangled by the curvature of space-time. You remember the black holes you've heard about, their event horizons, where time stops completely. The edge of the universe is a different kind of horizon, but it hums with the same eerie silence. You picture the expansion not as a balloon now, but as a movie that's still playing. Except as you move outward, the movie slows to a crawl, then to a single frame forever paused at the edge of comprehension. That's what the boundary of the observable universe feels like. A frozen frame, a still image of a time that can never update. Out here, you can sense why scientists call it look-back time. It's not distance that defines the edge, it's age. You can never see beyond 13.8 billion years, because that's how long light has had to travel. Beyond that, the cosmic fog of the early universe becomes impenetrable. There's no light to see, no signal to follow, just the hum of creation itself, still echoing in microwaves. If you could somehow travel to the edge, ride a photon all the way to its fading limit, you wouldn't find a border or a wall. You'd just see more of the same, only slower, dimmer, and older. The universe doesn't stop. Your ability to perceive it does. It's humbling, really. You live inside a bubble defined not by walls, but by time. You're trapped in your own cosmic light cone, a region carved out by the speed of light, by the finite patience of existence. Everything outside that cone remains invisible, unknowable, unreachable. But the most poetic part, you're creating your own horizon right now. Every second you exist, more of the universe slips beyond your reach, carried away by expansion. The edge is always receding, always one step ahead of your understanding. So, you let it go. You close your eyes and breathe. The stars blur into streaks of faint color, red shifting into nothing. Time stretches, folds, then finally feels still. You're no longer watching the universe move. You are the movement, unfolding with it, second by second, toward eternity. You glide deeper into that cosmic twilight, where time begins to melt, and the faint hum of the past starts to sing. The silence turns into something soft and resonant, the faintest microwave whisper echoing through every direction of space. This is the oldest light in the universe, and it's been traveling toward you for nearly 14 billion years. It's called the Cosmic Microwave Background, or CMB. But tonight, it's more like a lullaby than a scientific artifact. You imagine it as a warm, faded glow painted across the inside of an invisible sphere surrounding you. No matter which way you look, the same ancient afterglow greets you. It's the ghost light of the first stars, a leftover shimmer from when the universe itself was only 380,000 years old, just a baby with a loud cry of creation. The mainstream science says this radiation is the remnant heat from the Big Bang, stretched and cooled by billions of years of expansion until it now glows just a few degrees above absolute zero. But when you close your eyes and picture it, you can almost hear it. A soft hiss, the echo of birth, like the static between radio stations. You drift within it, wrapped in the gentle warmth of something impossibly ancient. For a moment, it's as if the universe is holding you close, whispering, "You're part of me, and I remember you." The light you're bathing in isn't uniform. It has tiny ripples, microscopic differences in temperature, no more than a few millionths of a degree. But those ripples are the seeds of everything. Every galaxy, every star, every atom in your body started as a wrinkle in this cosmic baby blanket. The faint unevenness in the CMB is the universe's handwriting, proof that even perfection needs a little chaos to create something beautiful. You remember that somewhere in the 1960 seconds, two radio engineers named Penzias and Wilson accidentally discovered this glow while trying to clean up what they thought was noise in their antenna. They even checked for pigeon droppings, convinced it was an equipment issue. But what they found was the echo of the Big Bang itself, a cosmic hum that had been playing unnoticed for billions of years, right above our heads. Scientists still argue whether those early fluctuations were purely random or if they hint at something deeper, a kind of hidden pattern beneath the universe's skin. Some fringe physicists believe that those temperature ripples might be the fingerprints of another universe colliding with ours in the distant past. If true, then the CMB might be less a photo of our beginning and more like the scar tissue from an ancient cosmic impact. But you're not here to solve that mystery tonight. You're here to feel it, to let it wash over you like gentle heat from a dying fire. You open your eyes and imagine the early universe, glowing white-hot, expanding faster than thought. Hydrogen and helium swirling like fog, photons bouncing endlessly off charged particles, trapped in a glowing soup. Then suddenly, it all changes. The universe cools, the fog clears, and light breaks free for the first time. The universe becomes transparent, and that first light has been traveling ever since, uninterrupted, unstoppable, arriving here, right now, in this quiet moment. As you drift, you realize that the night sky above you isn't just a map of stars. It's a photograph of the past. Every direction you look points to a different era. The farther out you gaze, the younger the universe becomes, until at the very edge of perception, you see this faint afterglow, the universe's baby picture. And if you were to travel beyond it, if you somehow you'd reach a time before light, before atoms, before anything could even be called real, you'd find yourself in the opaque, hot plasma that existed just after the Big Bang, where matter and energy were indistinguishable. Beyond that, the physics you know starts to crumble. It's comforting, in a strange way, that the universe keeps some secrets. It's like a parent gently saying, "That's far enough, little one." Yet the ghost light still calls to you. It's the most democratic light imaginable. Every inch of space is soaked in it. Even between galaxies, in the darkest voids, this ancient glow hums softly. The CMB is the universe's memory of its own birth, and you're floating through it like a dream. You can't help but smile at the thought that every living thing, every planet, every atom, once shared this same glowing nursery. The heat that once filled the entire universe now sits faintly on your skin as you lie beneath the stars. The very energy that gave rise to everything you know still lingers, stretched thin, but never gone. One quirky fact: scientists once turned this ancient radiation into sound. They translated its frequencies into audio, compressing billions of years into a few seconds. The result was a deep, droning tone, a kind of cosmic ohm. You might laugh, but somewhere between science and spirituality, that sound feels like the universe exhaling. So you listen. You imagine that hum as a heartbeat, faint but steady. You picture the ripples of the early cosmos expanding outward, cooling, and dimming into this eternal background glow. Every breath you take tonight carries a little of that same energy. You are, in every literal sense, made of this light. You are the afterglow, and as you float in it weightless, timeless, you realize that the edge of the universe isn't ahead of you or behind you. It's inside you. You're the living continuation of that first flash of creation, carried forward through billions of years of change. The whisper fades, but the warmth remains. You drift onward, following that last thread of ancient light as it stretches into darkness, where visibility ends and imagination begins. You keep gliding outward, past the ghost light of the first stars, into a region where even ancient photons begin to fade. You're now approaching the true edge of the observable universe, the last place light can possibly reach before vanishing into the unseeable beyond. The silence here is absolute. No new galaxies flicker in the distance. No faint afterglow hums in your ears. This is where sight itself gives up. The universe hasn't stopped existing here. It's just gone dark to your eyes. You've reached what cosmologists call the cosmic horizon, a kind of speed limit for observation. You might imagine it like standing on a beach at night. The waves still stretch endlessly into the dark, but your eyes can only see the silver edge of moonlight on the nearest breakers. The rest of the ocean is still there, roaring, shifting, alive but beyond your perception. The universe works the same way. Scientists estimate that this visible bubble has a radius of about 46 billion light-years in every direction. Beyond that, the expansion of space itself carries galaxies away faster than light can bring their image to you. Their signals are still on the way, sure, but the universe is expanding faster than they can travel. It's like trying to run up a down escalator that speeds up with every step. For you, this is both thrilling and unsettling, because it means that somewhere beyond this invisible line, there could be entire cosmic continents of galaxies, clusters, and superclusters, worlds upon worlds you'll never, ever see. Some scientists call it the unobservable universe. Others prefer the inflationary beyond. You might think of it as the part of the movie that hasn't been projected yet. The reel keeps spinning, but the light from the projector can't reach the screen in time. It raises a deliciously troubling question. If light can't cross that horizon, what else can't? Does cause and effect break down there too? Can you even talk about what lies beyond if you can never measure it? The truth is, no one knows. Some physicists, ever the optimists, believe that beyond our horizon lies simply more of the same. More galaxies, more dark matter, more of the cosmic web, stretching without end. To them, the universe has no edge, no border, just a gradually fading continuum of matter and energy. Others, however, whisper bolder ideas. What if the universe doesn't extend infinitely? What if it loops back on itself, like the surface of a sphere? Travel far enough in one direction, and you might eventually return from the other side. Though at a scale so vast, it defies all possible human comprehension. Still, there's another school of thought, one that creeps in like a soft chill. What if beyond doesn't exist at all? What if the observable universe is the universe? Full stop. And everything outside it is nothing. No space, no time, not even void. The idea sounds impossible, yet it's completely consistent with general relativity. Space itself doesn't exist without the energy and matter that shape it. Beyond the last atom, there may be nowhere to go. Scientists still argue whether space is truly infinite or just unbounded. Unbounded means there's no edge, yet it's finite like the surface of a balloon. You could travel forever without falling off, yet the area is contained. The irony? The more the universe expands, the less we can ever prove which is true. Fringe thinkers sometimes take this to an extreme. They suggest that beyond the observable universe, reality could restart with entirely different laws. Another domain of existence where gravity doesn't pull, where light moves differently, where time might even run backward. In that sense, each horizon could be like a cosmic shoreline, separating not just regions, but realities. You pause, floating in that thought, watching faint starlight stretch and thin like pulled silk. What if your universe is just one bubble among countless others in a foaming sea of space-time? Each bubble, perhaps, a self-contained cosmos with its own Big Bang, its own physics, its own story. That's one of the strangest and most captivating ideas in modern cosmology, the multiverse hypothesis. And it all begins right here, at this invisible boundary. But before you drift into that infinity of infinities, you take a deep breath, because here, in this silent place, you can almost feel the curvature of reality. The light that reaches you is curved, redshifted, stretched. It's as if the universe itself is sighing, trying to tell you that there's always more than meets the eye. You think about how your own body is part of this grand geometry. Every particle in you was once packed inside a volume smaller than an atom. In the earliest moments of creation, you've been expanding ever since, not just across space, but across time. And yet, the irony remains. You'll never see beyond your own horizon. You'll never know what's out there. Even if you could travel at light speed, space would expand faster, always keeping the edge one step ahead. The more you chase it, the farther it runs. It's frustrating, yes, but it's also beautiful, because that means the universe is not just big, it's alive in a way. It grows faster than its contents can explore it, like a story still being written, even as you read it. You close your eyes and imagine that boundary again, not as a wall, but as a veil. Thin, shimmering, vibrating with the faint echo of creation. Behind it, perhaps, more stars wait. Or maybe nothing does. Either way, it's the purest mystery there is. And as you hover at the edge, weightless and aware, the last trace of light fades into perfect darkness. You're left with the soundless hum of your own thoughts, and the strange comfort of knowing that the universe will always keep something just out of reach. You stay suspended there, right on that invisible line between what's known and what's forever hidden. But your curiosity won't rest. You lean forward into the dark, as if leaning could somehow make the light arrive faster. Beyond that cosmic horizon lies the inflationary frontier, the region sculpted by forces so immense they set the entire universe in motion. The story begins less than a trillionth of a second after the Big Bang, when everything inflated, suddenly, violently, faster than light could ever dream of traveling. You might picture it like an air bubble in thick dough, expanding before the dough even knows it's been kneaded. One instant, it's smaller than an atom. The next, it's the size of a grapefruit. Then, a planet. Then a galaxy's worth of space, stretching faster than time can keep count. This was the cosmic inflation era, and it's the reason the universe looks so astonishingly uniform. The same temperature in every direction. The same faint radiation left over from birth. Inflation smoothed everything out, like a baker rolling dough flat before baking it into galaxies. But here's the twist. Inflation never truly ended. Not everywhere. Quantum fluctuations, the tiny random jitters that are built into reality itself, meant that in some places, inflation stopped. In others, it just kept going. Even now, somewhere far beyond your horizon, space is still ballooning faster than light, spawning new universes like cosmic soap bubbles popping and forming in eternal succession. That's the unsettling idea of eternal inflation, that creation never stopped. It simply moved beyond our reach. You're living inside one of countless pockets where the expansion slowed down enough for stars, planets, and life to form. The rest of reality? Still exploding outward, endlessly. Imagine this. You're floating in a field of infinite balloons. Each balloon is a universe, sealed off from the others, expanding into the same grand nothing. You can't see the next one over, because its light will never reach you. And yet, from its perspective, it's you who lie beyond the edge. That concept, the multiverse, isn't just science fiction anymore. Serious cosmologists toy with it, debate it, and sometimes lose sleep over it. Some argue that each bubble universe might have different physics entirely. Gravity could be stronger, light could move slower, hydrogen might not even exist, Others might have no matter at all, just smooth, empty energy fields humming forever in silence. Scientists still argue whether eternal inflation means an infinite number of universes or just an enormous number that never ends in practice. Infinity is a slippery thing. It's easy to say, impossible to measure. But in this theory, your entire cosmos, everything you know, is just one snowflake in an endless blizzard of creation. You can't help but grin at the absurdity. Somewhere, in another universe, there could be a version of you who didn't click on this video tonight. Maybe one who's still scrolling through recommendations, wondering whether to fall asleep to ocean sounds or astrophysics. And somewhere else, maybe a universe where you never existed at all because the laws there didn't allow chemistry, or stars, or dreams. It's both humbling and comforting, isn't it? The idea that existence doesn't hinge on your universe alone, that creation keeps experimenting endlessly. If one cosmos collapses, another blossoms in its wake, like a flower blooming in the ashes of its twin. Of course, this is where the science meets the fog. We can't observe beyond our cosmic horizon, and we probably never will. Every bit of data we gather, every photon that reaches our telescopes, comes from inside our own bubble. The rest is inference, mathematical whispers about what might lie beyond. But there's a clue, faint and strange, hiding in the cosmic microwave background, that afterglow of the Big Bang. Some scientists claim to have spotted circular bruises or cold spots, subtle distortions that might be scars from our universe bumping against another during its infancy. Imagine two soap bubbles colliding and briefly fusing before drifting apart again. If that's true, our cosmos once touched another, and the mark of that cosmic handshake still lingers in the oldest light we can see. Skeptics roll their eyes, of course. Those cold spots could be statistical noise, not evidence of a cosmic collision. But the allure is undeniable. If even one of those bruises is real, then you're not just living in a universe, you're living among them. Fringe thinkers take it further still. They propose that our Big Bang was actually a big bounce, a rebound from a previous universe that collapsed under its own gravity. The energy from that implosion then triggered another explosion, and so on, in an eternal cycle of expansion and rebirth. You're not witnessing the first act, in other words, but maybe the billionth. You drift through this thought like a dream. The cosmos, breathing in and out, forever. A heartbeat made of time itself. And what about the edge, you wonder? If inflation keeps bubbling forever, does that mean there's no ultimate boundary? Maybe the real edge isn't a wall at all, but the limit of what your particular pocket of existence can ever know. Beyond that, reality keeps rolling dice, trying every combination, creating every possible version of existence. Some philosophers suggest that if everything that can exist does exist somewhere, then all possibilities, every star, every choice, every you are as real as this one. You're not just a person lying in bed, listening to this voice. You're a ripple in an infinite sea of being, one note in a symphony that never ends. It's easy to feel small out here, staring into a multiverse that stretches beyond imagination. But maybe the better word is connected. You are, after all, part of the same process that built it, all the same quantum breath that still stirs the void. You close your eyes, not to escape the vastness, but to let it wrap around you like a blanket. Somewhere, universes are still being born. Somewhere else, others are fading away. And here you are balanced perfectly between them, listening to the hum of infinity. As you hover in the quiet expanse, your thoughts drift to dark energy, that invisible hand stretching the universe apart. It's subtle, nearly imperceptible, yet it governs everything beyond your horizon, like a conductor waving an unseen baton over an orchestra of galaxies. Every distant cluster, every isolated star, every photon you can barely detect, owes its motion to this enigmatic force. Dark energy wasn't always known. It slipped into scientific awareness in the late 1990 seconds, when astronomers noticed something astonishing. Galaxies aren't just moving away from each other, they're accelerating. Imagine throwing a paper airplane and then watching it speed up on its own. That's basically what the universe is doing. Scientists still argue whether dark energy is a constant property of space, a dynamic field, or a hint at a flaw in our understanding of gravity. As you imagine this expansion, you realize it's not like a balloon with clearly marked edges. Space itself is stretching, carrying galaxies along. There's no center, no outermost point. You could pick any spot and see the same effect. Everything moving away from you. And yet, despite its relentless push, the universe isn't uniform everywhere. Cosmic structures, clusters, filaments, walls, and voids remain gravitationally bound, forming a web that stretches across unimaginable distances. This cosmic web is mesmerizing. It's composed of galaxies strung along filaments like dew on a spider's web. Between these filaments lie vast voids, areas nearly empty of matter, yawning across tens or hundreds of millions of light years. You can almost imagine yourself drifting along one of these filaments, a solitary speck in a structure so massive it dwarfs comprehension. Here, at the frontier, dark energy dominates, slowly pushing unbound galaxies beyond each other's reach. These galaxies recede so quickly that in a few tens of billions of years, they'll vanish from view entirely, fading into cosmic oblivion. Future civilizations, if any exist, may peer into the night sky and see nothing but their own local cluster, a lonely island in a sea of darkness. But even here, your imagination wanders to the quirky side of cosmology. Some theorists suggest that dark energy might not be constant. It could vary over time, or even flip its nature entirely, turning from repulsion to attraction. In such a scenario, the universe's acceleration could halt, slow, or even reverse, hinting at the possibility of a cosmic contraction, the so-called Big Crunch. Scientists still argue whether dark energy is truly a property of the vacuum or a signal of a deeper, hidden physics yet to be discovered. Amid this accelerating void, you begin to notice the subtle interplay of gravity and dark energy. Massive clusters resist the expansion for a while, like a boulder held under an elastic sheet that is being stretched from all sides. Galaxies inside these clusters orbit each other, bound together, resisting the pull of expansion. But eventually, even these cosmic fortresses may succumb as dark energy continues its relentless push. You imagine drifting past a supercluster, a glowing congregation of hundreds or thousands of galaxies. The gravitational ballet is intricate. Galaxies weave around one another, some colliding, others passing in near misses, each trajectory shaped by invisible forces. It's a dance, choreographed over billions of years. And you, floating silently, are a silent witness to its grand rhythm. A quirky thought sneaks in. Consider the possibility that some regions of space might be isolated forever, effectively unreachable by any traveler, no matter how fast or clever. Some cosmologists even speculate that civilizations in these isolated pockets may never know of the broader universe. Their observable sky could be eternally confined to their local cluster, unaware of distant structures like the Great Attractor, the South Pole Wall, or even our Milky Way. You pause, picturing the timeline of everything around you. Stars are aging, galaxies slowly dimming, clusters bound together by gravity but moving away from others. The cosmic web you float along is still majestic, yet it exists under a quiet, inexorable pressure. The expansion of space. It's both awe-inspiring and slightly melancholic, a reminder that even the grandest structures have an expiration date, stretched thin by the universe's relentless acceleration. Fringe thinkers sometimes go further, suggesting that dark energy might eventually tear apart everything in a hypothetical Big Rip. Galaxies, stars, planets, and even atoms could be disassembled if the repulsive force of dark energy overwhelms gravity and atomic cohesion. Scientists still argue whether such an end is possible or if it's merely a mathematical extrapolation stretching far beyond what can be physically tested. You smile at the thought, a gentle shiver of existential awe running down your spine. Floating here, at the edge of everything we can see, you realize that the universe is less a static backdrop and more a living, stretching, evolving canvas. Dark energy isn't just a curiosity. It's a central character in the story of everything. And while you drift, suspended in this serene cosmic flow, you start to appreciate the subtle beauty of expansion. It's patient, imperceptible in a human lifetime, yet unstoppable over eons. And even as galaxies fade beyond the horizon, even as dark energy stretches the fabric of space ever thinner, the universe hums with the quiet persistence of existence. Now, as you glide further along the cosmic river, your attention turns to the cosmic microwave background, the faint, ghostly afterglow of the Big Bang. You might imagine it as the universe's baby picture, frozen in light and stretched thin by 13.8 billion years of expansion. Everywhere you look, the CMB whispers about the infancy of everything, a faint hum left over from when the universe was just a searing soup of particles. You wrap your mind around this. The light you're detecting left its source long before the Earth, or the Sun, or even atoms themselves existed. Photons from the CMB have been traveling uninterrupted for eons, stretched into microwaves as space expanded. It's like holding a postcard that traveled across a universe-sized ocean to reach you. And when you read it, it tells you the story of the universe's first few 100,000 years. Within this glow lies a surprising secret. Tiny fluctuations in temperature, mere millionths of a degree, encode the blueprint for all the structure you now see. These slight density variations dictated where matter would collect, forming the first stars and galaxies. The universe's earliest whispers of order are hiding in the most delicate patterns of the CMB, almost as if it were a cosmic Morse code waiting to be decoded. But there's more. Some cosmologists have detected curious anomalies in the CMB, like the so-called cold spot, an unusually large area cooler than its surroundings. Could this be a shadow from another universe bumping into ours? Or just a statistical fluke? Scientists still argue whether these anomalies hint at collisions with other bubble universes, or are simply quirks of chance. Either way, the cold spot sparks your imagination, suggesting the possibility of realities beyond our own, lying just outside our cosmic horizon. As you drift, you realize that these CMB photons are also a time machine. Each photon carries information from a time when the universe was opaque, a dense fog of electrons scattering light in every direction. Then, as the universe cooled, light finally escaped, allowing the cosmos to become transparent. What you see now is light that has journeyed almost 14 billion years, telling the story of when time itself was young. Floating further, your gaze falls upon the large-scale structure, the cosmic web you glimpsed earlier. Filaments stretch across hundreds of millions of light-years, with galaxies strung along their threads. Between these filaments, vast voids yawn. The interplay of gravity and dark energy has molded this tapestry into a grand network, a three-dimensional spider web that is both delicate and resilient. You feel a strange kinship with it, both structured yet unpredictable, shaped by rules and randomness alike. Here's a quirky mental image. Imagine the cosmic web as a delicate lace doily, its threads shimmering faintly in microwave light, each strand vibrating with the echo of ancient quantum fluctuations. And remember, the voids between the filaments aren't empty. They contain dark energy and dark matter, unseen, mysterious, yet crucial to the universe's evolution. Scientists still argue about the precise role of dark matter in shaping this structure. We know it outweighs normal matter by a factor of 5, and its gravitational pull guides galaxies along filaments and into clusters. But its composition remains elusive, a cosmic phantom. Could it be WIMPs, axions, or something even stranger, lurking beyond detection? You imagine what it's like to travel through this web. Even if you could move faster than light or slip through a warp bubble, you'd never escape the influence of these massive structures. Gravity tugs relentlessly, curving your path, subtly bending the light you see, reminding you that even in a seemingly infinite void, forces are at play that guide the universe's slow dance. Meanwhile, those ancient photons remind you of your own fleeting existence. Just as the CMB has traveled billions of years to reach you, your life is but a brief ripple in the ongoing story of everything. Yet, that ripple matters. It allows you to witness, to imagine, to float along the cosmic currents and contemplate infinity. And as you glide along the cosmic web, you realize the universe isn't silent. Even in the vacuum of space, subtle vibrations, the faint hum of background radiation, the gravitational murmurs of distant black holes, all contribute to the music of existence. It's the kind of music that lulls you gently into reflection, a reminder that even in a universe governed by immense forces, beauty resides in patterns and persistence. Drifting further, your mind lingers on the edges of observable space, where the light from distant galaxies has traveled for billions of years to reach you. Here, reality stretches into a strange, almost surreal perspective. You're not seeing these galaxies as they are now, but as they were when their light began its journey. Time itself becomes a tangible dimension. You are literally looking into the past, a cosmic memory unfolding before your eyes. It's humbling, The galaxy you see may no longer exist as you perceive it. Stars could have burned out, merged, or exploded in supernovae long ago. Entire clusters may have drifted apart or collapsed into black holes. And yet, their light persists, crossing the chasms of space, stubbornly carrying ancient stories to your senses. Scientists still argue how much of the universe beyond our horizon is fundamentally unknowable, whether the cosmos is infinite, or if unseen regions are forever inaccessible to us. As your consciousness drifts alongside this light, you become aware of the cosmic horizon, the limit of what we can observe. Beyond it lies a region that no signal, no photon, no gravitational ripple can ever reach us. It's a boundary dictated not by physical walls, but by the finite speed of light and the relentless expansion of space. Galaxies beyond this horizon are already receding faster than light relative to us, dragged along by the accelerating expansion. Even light from them will never arrive. Now, let's ponder the quirky, almost whimsical side of this frontier. Some cosmologists hypothesize the existence of pocket universes beyond our observable bubble. Imagine your universe as a single soap bubble in a cosmic foam, each bubble containing its own laws of physics. Could there be neighboring universes with different constants, where light bends strangely, chemistry behaves differently, or time flows backward? Scientists still argue whether these multiverse ideas are mere speculation or a real feature of cosmological reality. Meanwhile, your focus drifts to cosmic inflation, the incredible period when the universe expanded exponentially in the first fractions of a second. During inflation, space itself stretched faster than light, not violating relativity, but expanding the very fabric through which light traveled. This epoch set the stage for the large-scale structure you're now observing. Fluctuations in quantum fields during inflation seeded the density variations that became galaxies, clusters, and the vast cosmic web. You imagine these fluctuations as tiny ripples on an invisible pond, magnified across cosmic scales, now etched into the distribution of matter throughout the universe. What's remarkable is that these ripples, once subatomic, now govern the grand architecture of the cosmos. It's like a microscopic imperfection, creating a masterpiece over billions of years. Your mind wanders to dark matter again, the invisible scaffolding around which galaxies coalesce. This ghostly substance guides the motion of stars, the twisting of galaxies, and the paths of light. Without it, the universe would look drastically different. Filaments would dissolve, voids would expand, uncontrolled, and galactic structures might never have formed. Its invisible presence is almost poetic, an unseen architect of cosmic order. Floating further, you consider cosmic time dilation. Light from extremely distant galaxies doesn't just travel far. It also experiences the stretching of space-time itself. The redshift you observe isn't merely a Doppler effect. It's a record of the expansion of the universe over billions of years. A galaxy emitting ultraviolet light when the universe was a newborn now appears red, its photons elongated across the cosmic distance, whispering secrets of a younger universe. And then there's the subtle quark of oddity. Some astronomers suggest that the universe might be cyclic, undergoing endless expansions and contractions. Maybe this vast cosmic bubble you float in is just one phase of an infinite cycle, each expansion erasing the last, yet leaving traces in the fine-tuned laws of physics. Scientists still argue about the plausibility of cyclic universes, the role of entropy, and whether traces of prior cycles could survive in the CMB or dark energy properties. As you drift on this edge, you sense a profound duality. The universe is both knowable and unknowable. Every photon carries information, yet vast stretches remain forever hidden. Every structure obeys physical laws, yet anomalies and dark mysteries remind you of your limitations. And as your consciousness floats in this gentle paradox, you feel a deep, peaceful awe, suspended between the observable and the unobservable, a silent witness to the infinite possibilities lurking beyond the edge. As you continue drifting, your attention turns to cosmic voids, those vast, yawning expanses between filaments and clusters, often spanning hundreds of millions of light-years. At first, they seem like nothingness, empty regions devoid of galaxies, gas, or even light. But empty is misleading. These voids are sculpted by gravity and dark energy, shaping the distribution of matter around them and influencing the cosmic web. You could think of them as the universe's silent lungs, spaces that define the shape of everything else. Floating through one of these voids is eerily peaceful. You notice the faint glow of the rare galaxies peppered within lonely islands of light, adrift in darkness. These galaxies are small, often irregular in shape, and sometimes oddly isolated. They formed in regions where dark matter density was low, making them outliers compared to their bustling counterparts in clusters. Scientists still argue about the exact processes of galaxy formation within voids, debating whether these isolated galaxies experience slower evolution or entirely unique star formation histories. A quirky thought sneaks into your mind. Some theorists suggest that voids could contain alternate physics, tiny fluctuations in dark energy, or unusual quantum fields, simply because they are so underdense compared to the rest of the universe. While untested, the idea sparks a whimsical image. Maybe the laws of nature are slightly different in the vast emptiness, giving rise to phenomena we can barely imagine. As you float, you sense that voids are not static. Dark energy pushes against the surrounding cosmic structures, expanding these voids over time. Meanwhile, filaments and clusters at their boundaries pull inward, creating a dynamic tension that subtly shapes the universe's large-scale geometry. It's a cosmic tug-of-war, silent, slow, but relentless over billions of years. Then your attention is drawn to supervoids, rare, massive voids that dwarf ordinary ones. The largest known spans over 1 billion light-years, a space so vast that light crossing it takes eons. Within it, galaxies are sparse and temperatures slightly cooler, creating subtle effects in the CMB. Imagine a bubble in the fabric of the universe itself, almost imperceptible, yet leaving a signature across billions of light-years. Scientists still argue whether these supervoids formed through simple gravitational dynamics or hint at something more exotic in cosmology. You can't help but picture a quirky mental metaphor. Floating inside a supervoid is like being inside a room with walls of invisible rubber. The walls stretch, sway, and rebound in slow motion, shaping the movements of the stars and galaxies within. Even though the room seems empty, its presence is everywhere, subtly dictating the behavior of its contents. As you glide further, you notice that cosmic voids are not just empty spaces, they are laboratories for observing the universe's expansion. Since gravity is weaker here, the effects of dark energy become more pronounced. By measuring how galaxies move at void boundaries, astronomers can refine estimates of the universe's expansion rate, known as the Hubble constant, and probe dark energy's mysterious properties. Floating silently, you also consider that some theorists speculate voids could harbor exotic phenomena, like mini-universes with different physical constants, or even regions where space-time is slightly curved in unexpected ways. Scientists still argue whether these ideas are plausible or simply playful mathematical extrapolations, but they offer tantalizing possibilities beyond conventional cosmology. As the emptiness stretches around you, a quiet realization settles in. These voids, though seemingly barren, are fundamental to the universe's shape. Their silent expansion orchestrates the grand cosmic ballet, defining the web of matter, guiding galaxies along filaments, and creating the conditions for structure formation elsewhere. They are a paradoxical presence, emptiness shaping existence, silence defining music. And as you drift along, the faint light from distant galaxies and the whisper of ancient photons remind you of the scale of all this emptiness. You are floating in a universe defined as much by what is absent as by what is present. A universe where voids are not mere gaps, but active participants in the cosmic story. Now, your journey carries you toward the cosmic horizon, the ultimate boundary of what the universe reveals to you. Unlike the cosmic voids, this horizon isn't defined by emptiness or density. It's defined by light itself. Beyond this limit, galaxies recede faster than light relative to your position, their photons forever trapped in the expanding fabric of space, destined never to reach your eyes. You feel the subtle tension between curiosity and impossibility, the universe teasing you with secrets that cannot be unveiled. As you float along, the notion of inflationary bubbles surfaces. Some cosmologists speculate that the universe is one of many bubbles in a grander multiverse, each inflating separately and obeying potentially different physical laws. The bubbles never collide in ways detectable to us. Yet the theory provides a tantalizing explanation for fine-tuning in our own universe. Scientists still argue whether these multiverse concepts are meaningful predictions or just imaginative extrapolations of inflation theory. It's almost as if the cosmic horizon is a stage curtain, hiding not just space, but potentially an infinite ensemble of alternate realities. Your awareness drifts to light cones, a concept that defines causal limits. Even if you could accelerate a spacecraft to unimaginable speeds, you would never outrun the structure of space-time. Events beyond your light cone remain forever disconnected from your reality, emphasizing that the universe has a natural bookkeeping system. What you can affect and what you can observe is inherently limited. This is a little humbling, especially when you imagined casually hopping to a galaxy far beyond reach. Quirkier still, you imagine a cosmic version of a mail system. Messages from distant galaxies are parcels in transit, some arriving after billions of years, others trapped forever beyond the horizon. Light itself becomes both a messenger and a prison, carrying secrets of a bygone era while reminding you that not all stories are reachable. Scientists still argue about whether some information beyond the cosmic horizon could ever be inferred indirectly, through gravitational waves or other subtle cosmic signals. And speaking of gravitational waves, you begin to feel their faint tug. These ripples in space-time, created by colliding black holes or merging neutron stars, travel across the universe, oblivious to light's limitations. Even in regions beyond the horizon, these waves carry energy and information, adding a layer of subtle dynamism to areas you cannot directly observe. It's a reminder that the universe is never truly silent. Even where emptiness reigns, your imagination drifts to dark flow. An observed peculiar motion of galaxy clusters, seemingly moving toward an unseen mass beyond the observable universe. Could there be structures so massive that they tug at space-time itself, yet remain beyond your reach? Scientists still argue whether this is a real phenomenon or an observational artifact, but the thought adds to the mystery of what lies beyond the observable edge. You picture the universe's edge as a foggy cliff, with familiar landscapes fading into a haze of speculation. Beyond it, light has not yet reached, and the cosmic web may stretch infinitely, or perhaps terminate unexpectedly. The fog suggests possibility. Parallel bubbles, ancient voids, massive dark structures, or even regions governed by unknown laws of physics. Even imagining it feels like peering into the infinite unknown, a frontier of wonder and philosophical reflection. And here comes a quirk. Some theorists speculate that information might be fundamentally encoded at the edge of the observable universe, a sort of cosmic screen, storing every event that has occurred. It's a speculative extension of holographic principles, where the universe behaves like a hologram, projecting three-dimensional reality from two-dimensional boundaries. Scientists still argue whether this idea is mathematically sound or a metaphor, but it adds a poetic dimension to the edge of everything you know. As you hover near this horizon, it becomes apparent that the boundary is not just spatial, but temporal. Light from regions just inside your horizon reaches you now, billions of years after it was emitted. The further you look, the younger the universe appears. Observing this is like holding multiple snapshots of reality at once, each from a different cosmic age, reminding you that time and space are intertwined in ways that challenge your intuition. Finally, the cosmic horizon impresses upon you the limits of knowledge, the inherent tension between curiosity and cosmic scale. You understand that the universe is both accessible and forever elusive. Each photon, each gravitational ripple, each ancient fluctuation tells part of the story, but some mysteries remain cloaked beyond reach. And as your awareness drifts along this threshold, you realize that even in the face of the unknown, your contemplation, your wonder, adds meaning to the vast, silent cosmos. Drifting onward, your attention shifts to the mysterious role of dark energy, the invisible force accelerating the universe's expansion. Unlike gravity, which pulls matter together, dark energy pushes everything apart, subtly, relentlessly, and invisibly. Galaxies that once seemed bound by gravity are now drifting away faster each billion years, carried by this cosmic tide. Imagine trying to hold hands with someone on a treadmill, moving faster and faster. No matter how strong your grip, the pull eventually overwhelms you. Scientists still argue about the precise nature of dark energy, whether it is a cosmological constant, a dynamic field, or an indicator of physics we have yet to discover. You float among galaxies, noticing how their recession speed grows with distance. This effect is not a result of the galaxies moving through space, but space itself stretching between them. It's a subtle distinction, but it reshapes your understanding of motion. You feel a gentle vertigo as the cosmic fabric expands, stretching light itself. The photons from distant galaxies are elongated, shifted toward red wavelengths, a phenomenon known as redshift, a reliable cosmic yardstick for astronomers to gauge distances and expansion rates. A quirky mental image drifts into your mind. Imagine a universe as a stretchy taffy, with galaxies embedded like raisins. As the taffy stretches, the raisins drift apart, yet they themselves do not expand. They simply follow the rhythm of the expanding candy. In your imagination, some raisins even dance in peculiar ways, hinting at dark energy's unseen fluctuations. Scientists still argue whether subtle variations in dark energy could lead to long-term differences in cosmic structure formation. You notice the paradoxical elegance of this expansion. Voids grow emptier, filaments stretch, and clusters become increasingly isolated. Yet, the universe retains its large-scale web-like structure. It's a delicate choreography, balanced between the relentless push of dark energy and the pull of gravity, shaping the cosmic scenery around you. Imagine the quiet tension, billions of years in the making, sculpting every galaxy, every star cluster, every faint glimmer you observe. Your attention drifts to supernovae, particularly type Ia explosions, which astronomers use as standard candles to measure cosmic distances. These brilliant events serve as markers to map the universe's expansion. Observations of distant supernovae first revealed the accelerating expansion, a discovery so counterintuitive that it earned the 2011 Nobel Prize in Physics. Even now, you can imagine astronomers peering through telescopes, tracking these dying stars as beacons, while the universe stretches silently around them. Floating further, you encounter the concept of phantom energy, a hypothetical variant of dark energy with even stranger properties. If it exists, it could accelerate expansion to the point where galaxies, stars, planets, and eventually atoms themselves are torn apart in a hypothetical Big Rip. You shiver in your imagination at the audacity of this scenario, yet a sense of awe tempers the fear. Scientists still argue about the plausibility of phantom energy and whether any observational evidence could ever confirm it. You also notice how dark energy subtly influences cosmic microwave background (CMB) measurements. The relic radiation from the early universe is not uniform. Its slight anisotropies carry fingerprints of both dark matter and dark energy. These ancient patterns help scientists model how the universe has expanded and evolved over 13.8 billion years, giving us insight into both its origin and eventual fate. Quirkier still, some theorists speculate that dark energy might interact with dark matter in unexpected ways, forming subtle feedback loops that could affect galaxy formation and void growth. Although highly speculative, this idea opens doors to new models of the universe where unseen forces orchestrate the cosmic ballet behind the scenes. Scientists still argue about whether these interactions are detectable or purely theoretical. As you drift along, the slow, relentless influence of dark energy begins to feel like a cosmic heartbeat, pulsing through every corner of existence. It reminds you that the universe is dynamic on scales that dwarf human comprehension, yet intimately connected. The expansion affects your distant galaxies, the voids around them, and the very light that reaches your eyes. In this silent, expansive theater, dark energy is the invisible conductor, shaping the symphony of space-time and guiding your journey further toward the unknown edge of everything. Your drifting awareness turns toward the fate of galaxies themselves, as if the universe were a living organism gradually aging before your eyes. Galaxies are not static. They evolve, interact, and sometimes die in spectacular or subtle ways. Spirals slowly exhaust their gas, creating fewer new stars, while elliptical galaxies often contain only old, red stars drifting quietly in their stellar retirement. You can almost sense the faint hum of billions of suns fading into cooler, dimmer light. Scientists still argue how much interactions, mergers, and the influence of dark energy drive the life cycle of galaxies over cosmic timescales. Quirkier images enter your mind. Galaxies as cosmic cities, their starry populations bustling in youth, slowing to sleepy hamlets over billions of years. Supermassive black holes lurk at the cores, acting as cosmic mares with occasional tantrums, energetic jets, and radiation outbursts that can quench star formation across vast neighborhoods. These outbursts remind you that even the largest structures are fragile, vulnerable to forces both visible and unseen. As you float closer to a spiral galaxy, you notice stellar nurseries glowing faintly in clouds of gas and dust. These nebulae are cradles for young stars, where gravitational forces compress clouds into cores dense enough to ignite nuclear fusion. The process is slow, chaotic, and beautiful. Stars emerge, live luminous lives, and eventually die, feeding gas back into the galaxy's ecosystem. It's an endless, quiet cycle. Scientists still argue whether star formation rates have declined uniformly across the universe, or if certain environments remain unusually fertile. A quirky tidbit drifts through your imagination. In some rare galaxies, star formation may occur in bursts triggered by cosmic collisions, like an interstellar fireworks display. You can almost hear the faint hiss of supernova remnants echoing through the void. Reminders that endings can also become beginnings in the cosmic narrative. As you follow this galaxy's rotation, the arms spiral gracefully, guiding the movement of stars and gas. Gravity acts like an invisible choreographer, and yet dark energy subtly tugs from afar, stretching the fabric around the galaxy. Over billions of years, galaxies move farther apart, star formation slows, and clusters become increasingly isolated. It's a quiet drama unfolding across unimaginable distances, with consequences too slow for human perception, but fundamental to the structure of the cosmos. Your mind wanders to galactic cannibalism, a phenomenon where larger galaxies absorb smaller neighbors, merging stars and dark matter into new configurations. You imagine a small, irregular galaxy being slowly devoured, its stars scattered into streams that wrap around the host galaxy. Scientists still argue about the frequency of such mergers in the early versus modern universe, and how they influence the growth of supermassive black holes at galactic centers. Meanwhile, in the empty outskirts, rogue stars drift alone, ejected by gravitational interactions or supernova explosions. These lonely travelers wander through the intergalactic medium, perhaps carrying planets with them or merely moving silently through darkness. They are reminders that not every star participates in the orderly dance of galaxies. Some are castaways in the cosmic ocean. A playful thought surfaces. Imagine a lonely star club, a cosmic social network for stars without galaxies, exchanging nothing but gravitational whispers. You smile at the absurdity, yet it emphasizes the universe's diversity, the surprising variety hidden even in apparent emptiness. Scientists still argue about how these stars affect the intergalactic medium, seeding it with elements for future generations of cosmic structures. As you drift farther, the interconnected web of galaxies, voids, and filaments becomes apparent again. You realize that every galaxy's fate is intertwined with the universe's expansion and dark energy's invisible hand. Even the tiniest fluctuations in mass, the faintest tug from a nearby cluster, or the eventual dimming of a star, all contribute to the slow, majestic evolution of the cosmic landscape. In this vast, patient universe, galaxies are both actors and witnesses in an eternal drama, their lives and deaths echoing across billions of years, toward a future shaped by both visible and invisible forces. Now, you drift toward the enigmatic black holes, the universe's ultimate sinkholes, where space-time twists and time itself seems to slow. These cosmic vacuum cleaners are both terrifying and fascinating. Supermassive black holes sit at galaxy centers, anchoring stars with invisible gravity, while occasionally launching energetic jets across thousands of light years. Stellar mass black holes, remnants of massive stars, drift more quietly, often invisible, except when feeding on nearby material. Scientists still argue about the exact role of black holes in galactic evolution, whether they merely observe or actively shape their environments. Imagine a black hole as a cosmic whirlpool, sipping gas, dust, and occasionally entire stars. The warped space-time near its event horizon bends light and distorts reality itself. A quirky thought. If you hovered safely near one, you might see yourself aging slower than someone far away, thanks to gravitational time dilation, a natural cosmic time machine. Yet beware, you probably won't survive this experiment. Your awareness glides to Hawking radiation, a theoretical glow emitted from black holes over inconceivably long timescales. Even the most massive black holes slowly leak energy, imperceptibly evaporating over eons. In trillions upon trillions of years, nothing escapes entirely. But the universe whispers, hints of entropy and ultimate energy loss. Scientists still argue whether Hawking radiation can be observed directly or remains a beautiful theoretical concept. Quirkier still is the notion of primordial black holes, tiny remnants from the early universe, potentially formed from density fluctuations shortly after the Big Bang. These miniature enigmas could act as dark matter candidates, silently influencing the structure of galaxies and the universe at large. Imagine a particle smaller than a mountain, yet with a gravitational pull so intense it warps space-time around it. Scientists still argue about whether these black holes exist or are merely elegant mathematical solutions. As you drift further, your attention turns to gravitational waves ripples in space-time, created by massive, accelerating bodies like merging black holes. These waves pass through the universe almost unhindered, carrying secrets of cataclysmic events across billions of light years. You can almost feel their faint vibrations in the cosmic fabric, a subtle reminder that even the darkest, most isolated phenomena leave traces. Scientists still argue how gravitational waves might interact with dark energy or large-scale cosmic structures. You notice the relationship between black holes and galaxies. Supermassive black holes regulate star formation via feedback processes. Jets and outflows can compress or expel gas, influencing stellar nurseries. Some black holes lie dormant, quietly consuming occasional stray material, while others flare dramatically, transforming nearby regions. It's a slow cosmic conversation between gravity and energy, and you are a silent observer of its gentle, terrifying rhythm. Quirky mental image. Imagine black holes attending a cosmic tea party, sipping on streams of gas and occasionally burping jets of X-rays into their galactic surroundings. Odd, whimsical, but somehow fitting for these extreme objects. Scientists still argue about how these interactions scale across cosmic time, whether the early universe behaved differently, and how black holes influenced galaxy formation. Your thoughts wander to event horizons and their strange properties. The surface isn't a physical boundary, it's the point of no return, where the escape velocity exceeds the speed of light. To an outside observer, objects approaching an event horizon appear to freeze in time, their light increasingly redshifted, fading into oblivion. You picture a star slowly disappearing at the edge of a black hole, an eternal cosmic fade-out. Finally, your imagination stretches to black hole mergers, events that send out some of the most energetic gravitational waves in the universe. Two massive bodies spiral inward, colliding and merging, reshaping space-time in a cataclysmic yet distant dance. Even these dramatic events follow the gentle, patient pacing of the universe. You feel both awe and calm, knowing the cosmos balances destruction with rhythm and structure, echoing far beyond what your eyes can see. Floating further into the void, your attention turns to cosmic filaments and voids, the vast scaffolding of the universe, stretching across hundreds of millions of light years. These filaments are highways of galaxies, strings of matter woven into a delicate, web-like structure, while immense voids sit between them, vast regions almost entirely empty of stars. You drift along a filament, noticing how galaxies align like pearls on a cosmic string, each gravitationally tugging on its neighbors. Scientists still argue how exactly dark matter and dark energy orchestrate this grand web, and whether smaller-scale structures might be hiding surprises we have yet to observe. A quirky thought sneaks in. Imagine a cosmic spider weaving an intricate web across the universe, each filament a silk thread, with galaxies like dewdrops sparkling in the morning light. The spider, of course, is invisible, represented perhaps by dark matter, silently guiding the web's formation. You feel a gentle vertigo, realizing that the scales involved dwarf imagination. Filaments longer than the distance light travels in tens of millions of years, voids almost unimaginably vast. Your mind drifts to the Great Attractor, a mysterious gravitational anomaly tugging at our Milky Way and neighboring galaxies. You feel the faint cosmic pull as if your vessel is gently nudged along invisible currents. The Great Attractor is not a single object, but a massive region, potentially containing hidden galaxy clusters and enormous concentrations of dark matter. Observing it directly is nearly impossible due to the zone of avoidance, where the Milky Way's dust conceals the view. Scientists still argue about its composition and exact influence, but its effect is undeniable. Our galaxy is moving at hundreds of kilometers per second toward this unseen gravitational well. Quirkier mental picture. Imagine the universe as a giant cosmic river, galaxies as boats, and the great attractor as a hidden whirlpool pulling everything gently downstream. Some boats follow the flow without noticing, others resist, but eventually, all are subtly guided by this invisible hand. It's a strange and poetic metaphor, but it captures the essence of gravitational influence across cosmic distances. You drift farther, contemplating the South Pole Wall, a colossal structure spanning at least 700 million light-years. It's a dense cluster of galaxies that bends the local expansion of space itself. Galaxies between Earth and the wall move faster than expected, while those beyond it move slower, held back by its gravitational pull. This subtle imbalance is a delicate signature of the unseen structures shaping our cosmic neighborhood. Scientists still argue how such massive walls formed, whether through gravitational collapse, cosmic inflation, or interactions we haven't yet imagined. As you glide along, the interplay between filaments, voids, and massive structures becomes clear. The universe is not a random scattering of galaxies, but a dynamic, interwoven tapestry. Gravity and dark energy shape its large-scale structure, dictating the rhythm of cosmic evolution. You can almost hear the faint echo of motion, the gentle stretching and tugging of space-time itself. A quirky aside. Some theorists imagine a cosmic traffic jam, where galaxies pile up along filaments, waiting their turn to join clusters, like commuters in a galactic rush hour. You smile at the absurdity, yet it underscores a profound truth. Cosmic structures, despite the emptiness, follow patterns shaped by invisible forces, patiently sculpting the universe over billions of years. Finally, your gaze turns outward to the edge of the observable universe, the furthest light we can detect. Beyond lies uncertainty, regions we cannot see, where time and space might behave differently. Could there be other filaments, walls, or attractors we'll never detect? You float here, suspended between the known and the unknowable, aware that the universe is far larger than perception allows, and your journey through it is a meditation on scale, time, and cosmic patience. Scientists still argue whether the universe is infinite or merely unimaginably vast, beyond our observational limits. Floating deeper into the cosmic web, your mind settles on the grand architecture of filaments and voids, those vast, invisible threads that weave the universe together. Picture this: an intricate lattice stretching across hundreds of millions of light-years, where galaxies trace delicate filaments like dew on a spider's web, while yawning voids, immense and silent, punctuate the cosmic landscape. You drift along one of these filaments, feeling the subtle pull of gravity as galaxy clusters nudge each other in a slow, celestial dance. Scientists still argue about the precise influence of dark matter in sculpting these structures, and whether unseen forces could be shaping them in ways we have yet to measure. It's a quiet rhythm, almost hypnotic. You notice how these filaments converge at nodes, where massive clusters of galaxies gather, their collective gravitational pull dominating local space. A quirky mental image floats in. These nodes are cosmic roundabouts, galaxies endlessly circling, occasionally bumping gently into one another, merging over billions of years in a slow, stately waltz. It's chaotic yet serene, violent yet calm, a paradox that embodies the universe's patient nature. Scientists still argue about whether these nodes formed primarily from early density fluctuations or through later cosmic interactions, but their impact is undeniable. Your gaze drifts to the Great Attractor, a colossal gravitational anomaly subtly tugging at our Milky Way and countless neighboring galaxies. You sense its invisible pull, an almost imperceptible nudge guiding your vessel along its path. The Great Attractor is not a single object, but a region of space dense with galaxies, gas, and dark matter, most of which remains invisible to our telescopes. The zone of avoidance, hidden behind the dense plane of the Milky Way, shields it from direct observation. Scientists still argue about its exact composition, debating how much is ordinary matter and how much is unseen dark matter, orchestrating this cosmic tug-of-war. Imagine the universe as a river, with galaxies as boats drifting along, currents shaped by unseen hands. The Great Attractor is a whirlpool, pulling our Milky Way along at hundreds of kilometers per second. Yet, paradoxically, despite this pull, space itself expands relentlessly, separating galaxies that would otherwise drift together. You can almost feel the tension between gravity's gentle tug and the universe's inexorable stretching, a subtle reminder that the cosmos is both dynamic and patient. Nearby, the South Pole Wall emerges in your awareness, a colossal galactic structure extending over 700 million light-years. This wall exerts a gravitational influence, subtly bending the local expansion of the universe. Galaxies caught between Earth and the wall move outward slightly faster than expected, while those beyond it lag behind, held back by the wall's invisible hand. Scientists still argue about how such enormous walls could have formed. Did inflation amplify tiny quantum fluctuations? Or did vast regions collapse under gravity in the early universe? Either way, their existence hints at the astonishing scale and complexity of cosmic architecture. You begin to notice the interplay between filaments, walls, and voids. It's not random. Gravitational forces, dark matter, and cosmic expansion interact in a delicate dance, shaping where galaxies can form and how clusters grow. Quirkier still, imagine these structures as a cosmic game of connect the dots, where each filament is a string connecting distant points. Yet the dots themselves, galaxies, clusters, superclusters, shift and change over billions of years. The thought is whimsical, but it captures the meticulous, patient orchestration of the universe's large-scale design. Drifting further, your mind lingers on the voids themselves. Vast expanses, almost entirely empty of stars. These regions are silent and lonely, yet they play a critical role. They define the boundaries of cosmic structures, dictate the motion of galaxies along filaments, and provide contrast that makes filaments more perceptible. Scientists still argue about the void's potential influence on cosmic acceleration, suggesting that these immense emptinesses might amplify the apparent expansion we measure in nearby regions. You float toward a cluster at a filament's node, a collection of galaxies bound tightly together. Each galaxy holds hundreds of billions of stars, yet the cluster itself moves like a single, coordinated entity through space. Quirkier still, imagine the galaxies as a group of dancers at a slow, cosmic ball. each aware of its neighbors, yet moving to the same gravitational rhythm. You notice how gravity, though invisible, creates order from chaos, connecting stars, galaxies, and entire clusters in a coherent structure that stretches across incomprehensible distances. Scientists still argue about how interactions at these nodes influence star formation rates, black hole activity, and even the distribution of dark matter. Your attention now shifts to cosmic filaments stretching into the distance, connecting clusters separated by hundreds of millions of light years. These strands are like highways of matter, guiding the flow of gas, dust, and galaxies over time. You imagine them glowing faintly with intergalactic plasma, feeding material into clusters like rivers nourishing a valley. Quirkier thought. Picture tiny spaceships drifting along these invisible highways, lost travelers in a network shaped by invisible forces. Scientists still argue about how much matter exists in filaments versus clusters and voids, with many filaments remaining too diffuse to detect directly. Next, consider the influence of gravity on motion across these scales. While filaments guide galaxies along defined paths, local interactions within clusters can cause chaotic orbits, mergers, and collisions. Over billions of years, some galaxies merge, some are ejected, and some slowly fade into obscurity. Yet overall, the grand web maintains its coherence. Quirkily, it's like a cosmic ant farm. Individual ants wander unpredictably, yet the colony persists in a structured, self-organized system. Scientists still argue how large-scale cosmic flows like those driven by the Great Attractor interact with local dynamics in clusters. Finally, you drift toward the edges of known structures, where filaments thin into the void and galaxies become sparse. Here, the universe feels both immense and intimate, vast, yet comprehensible. You reflect on how much of the universe remains hidden. Unknown filaments, undiscovered clusters, and regions beyond the reach of our telescopes. It's a reminder that every observation is a glimpse, not a complete picture. Scientists still argue about the overall topology of the cosmic web, whether it extends infinitely or bends back in ways we cannot yet measure. In this slow, meditative drift, you notice a pattern. The universe is a conversation between matter, energy, gravity, and time, unfolding over billions of years. Filaments, walls, and voids are its sentences. Clusters and galaxies, its words. And here you are, a conscious listener, floating along this narrative, able to sense the rhythm, the tension, and the serene persistence of cosmic evolution. The universe is patient, it is immense, and in this quiet moment, you feel the subtle hum of its ongoing, gentle orchestration, a lullaby of stars, voids, and invisible hands shaping existence itself. Your journey now drifts to the farthest observable edges of the universe, where light has traveled for over 13 billion years to reach you. Here, galaxies appear as faint pinpricks, stretched and reddened by the expansion of space. You feel the immense scale. The observable universe is a sphere about 93 billion light-years across. Yet beyond this horizon, what exists is entirely unknown. Could there be regions where the laws of physics differ, or where matter and energy follow patterns we cannot yet imagine? Scientists still argue whether the universe beyond our observational limit is infinite, or if there's a hidden boundary to space itself. Quirkier musings drift in. Perhaps entire cosmic civilizations exist there, watching their own sky, pondering universes just beyond their reach, not knowing that you are doing the same. You imagine a faint cosmic mirror, reflecting parallel observers across unimaginable distances, each isolated yet connected through the fabric of space-time. The thought is dizzying, yet comforting in its symmetry. Turning your awareness inward, consider dark energy, the mysterious force accelerating the expansion of the cosmos. As galaxies move apart faster and faster, even light itself cannot bridge the growing gaps in the distant future. Cosmic islands will drift beyond view, leaving isolated pockets of matter and light, quietly aging in near-perfect solitude. Scientists still argue how dark energy will influence the ultimate fate of the universe, whether it will continue forever, accelerate into a big rip, or fluctuate in ways we cannot predict. Quirky visualization. Picture the universe as a cosmic loaf of raisin bread rising in a cosmic oven. Each raisin, a galaxy moving farther apart, yet connected by invisible dough, stretching beyond comprehension. You might giggle at the absurdity, yet it's an oddly accurate metaphor for how space itself expands. Nearby, you sense cosmic microwave background radiation, the afterglow of the Big Bang. This faint, uniform light fills all of space and provides a map of the universe's earliest moments. Tiny fluctuations in its temperature reveal the seeds of galaxies, clusters, and walls that would form over billions of years. Scientists still argue over the interpretation of subtle anomalies in this radiation and what they may hint about physics beyond the standard model. Your mind drifts to quantum fluctuations, tiny variations in energy that existed in the earliest moments of the universe. These minute irregularities were amplified by cosmic inflation, giving rise to the large-scale structure of the cosmos. You can almost feel the trembling of space-time in its infancy, a gentle cosmic heartbeat that persists even today. Quirkier thought. Imagine the universe as a massive drum, struck once in a primordial flash, sending vibrations that ripple across eons and light years, echoing into the distant future. You float on these waves, aware of your smallness, but also of your connection to the entire cosmic symphony. As your journey slows, you glimpse potential multiverses, regions beyond our own universe, with entirely different physical constants, dimensions, or even laws of causality. While speculative, the idea suggests that our cosmos might be one bubble among many, each evolving independently. Scientists still argue whether these multiverses exist or remain purely theoretical. Yet the possibility sparks awe and curiosity. Your attention softens toward the quiet future. After trillions of years, stars will die, galaxies will fade, and black holes will slowly evaporate. The universe will approach a state of maximum entropy, a deep, serene darkness where motion and light become rare. Yet even in this profound stillness, you feel a strange beauty, a universe patiently unfolding, with each epoch leaving its imprint on the grand cosmic tapestry. Finally, your consciousness drifts into a reflective calm, where the vastness and mystery of existence settle around you. You recognize that while the edges of the universe may be unreachable, exploring them in thought and in imagination connects you to the cosmic story. Every star, galaxy, and black hole is part of a narrative that spans time and space, far beyond human scales. And in this gentle, cosmic lull, you realize that your curiosity, your awe, and your quiet wonder are part of the universe itself, echoing across the silent, infinite void. Now, let your awareness slow even further. Feel the vastness around you, the infinite canvas stretching beyond what you can see or imagine. Each point of light, each subtle ripple of space-time, is distant yet intimately connected to you. There is no rush here, no urgency, only the patient unfolding of cosmic time, the slow, deliberate dance of galaxies, stars, and black holes across billions of years. Breathe in this quiet, expansive calm. Picture the universe not as chaotic, but as a serene, interconnected whole. Even the darkest voids have purpose, shaping the motion of galaxies, guiding the flow of matter, and preserving the memory of the Big Bang. You are a witness, a participant in this cosmic story, however small, however fleeting. Let the gentle pull of gravity and the whisper of dark energy lull your thoughts. Imagine yourself drifting along cosmic filaments, floating past stars that shine and fade, past nebulae where new light is born, and past black holes, guardians of mysteries you cannot yet touch. All is patient. All is still. As your mind softens, let the questions of the universe, its edges, its origins, its possible multiverses, fade into the background, leaving only wonder. Allow the enormity of space and time to ease your mind, letting curiosity mingle with tranquility. The universe is vast, timeless, and ever-expanding, and so too is the quiet serenity you carry within. Now, dim the lights, maybe turn on a fan for that soft background hum, and let the stars of your imagination carry you gently into sleep. Sweet dreams.